Hello, this is your teacher Barbara Rademacher, and my Saturday class informed me today that they were having terrible problems with writing the equations of parallel and perpendicular lines. So we're going to go over this again. In fact, what I told them was I would go straight to my math lab and do the problems there and even put the answer into the answer box to make sure I'm right. Okay, so we are going to do this. We're going to start off with number 10, which is the beginning in our homework, in their homework, of parallel lines. So what we have is a line going through the point 8, -9, and this line is parallel to the line 7x minus 6y equals 5. Parallel lines have equal slope. They have the same slope, the same exact slope. They know this. I know they know this. But that doesn't stop them from having trouble, which also makes perfect sense to me. Let's come down here. All right, our line is 7x. The given line is 7x minus 6y equals 5. Now I solve for the y term by subtracting the x term from both sides. And 5 is positive, so I put a plus. 7x minus 7x is 0. And I bring down the minus 6y equals negative 7x plus 5. Now 0 minus 6y is negative 6y. And to solve for y, I divide through by negative 6, divide by negative 6, divide by negative 6. So the slope of the given line is negative 7 over negative 6. The negative signs cancel, so positive 7/6. Now I use the point slope formula. Y minus y1 equals m times x minus x1. So taking a look back at the given point, y minus negative 9 equals 7/6 times x minus 8. Double check that, make sure it's right. Okay. Now, go to the extra step. Y plus 9 equals 7/6 times x minus 8. Now, to temporarily get rid of the fraction, because nobody likes fractions, I multiply by 6 over 1 where there's a fraction, and just by 6 where there is no fraction. Multiply both sides of the equation by the denominator of the fraction. The 6's cancel over here, which is why I multiplied by 6. Over here, 6y plus 6 times 9 is 54. Equals 7 times x minus 8. So 6y plus 54 equals 7x minus 56. I subtract 54 from both sides of the equation. (54 minus 54 is 0. So this will be 6y equals 7x minus 110. Sure do hope this is right. Divide by 6, divide by 6, divide by 6. So y equals 7/6 x minus 2 goes into 110 and 2 goes into 6. So divide both of these by 2 and you will have 55 over 3. So let me write that larger. Y equals 7/6 x minus 55 over 3. Now I'm going to go over to the answer box. Fraction tool. Eek, where did it all go? There we go. 7/6. Well, I would like it a little bigger, but not that big. There now. 7/6. So 7, 6, x minus fraction 55 divided by 3. Check answer. Whew, okay. It's so embarrassing to get a question wrong when you're a teacher. Not that it doesn't happen, of course. There now. All right, this is another parallel line, parallel to this line, and going through this point. All right, this is number 11. And all right, the point is -7, 9. And the line is all jumbled up. 5x equals 7y plus 3. I have to solve for the y term. We're not used to seeing it over there. So I will quickly subtract 3 from both sides and then turn it around. So this will be 7y equals 5x minus 3, which is exactly the same statement as 7y equals 5x minus 3. But now there's a sense of being comfortable with this form. Now we divide by 7, divide by 7, divide by 7. So our slope, which is all we really care about, is going to be 5/7. Let's write it over here. Okay. Now I use the point slope formula. Y minus y1 equals m times x minus x1. Y minus 9 equals 5/7. Yep. Times x minus -7. Take an extra step to get rid of that minus minus. There now. This would be a fairly easy problem to go ahead and distribute because that number and that number are the same. But since students have just started doing this, I don't see any reason to stress them. So I'm going to use the same method over and over again. How boring, but worthwhile. So I multiply this side of the equation by 7/1 and this side of the equation by 7. On the left, I'll have 7y minus 7 times 9, which is 63, equals, the 7's cancel, leaving me 5/1, which is 5, times x plus 7. So 7y minus 63 equals 5x plus 35. Now I add 63 to both sides of this equation. So I'll have 7y equals 5x plus 98. Now I'll divide by 7 and divide by 7 and divide by 7, and I'll get my Wabbit Emu calculator out. Oh, heck. All right, looking for my ROM. There it is. I just want to make sure 98/7, make absolutely sure that 98/7 is in its lowest form, and it's not. It's not, it's 14. So what we're going to have is y equals 5/7 x plus 14. Now I come over to the answer box. There. Five sevenths x plus 14. Let's see if that's right. Woohoo! Next problem, number 12. Perpendicular. Danger, danger. Okay, we go to a whole new page. Our point is for 5, and the given number is 5x. The given equation is 5x plus y equals 3. And whether our equation is parallel or perpendicular, we still go to the given line for the slope. But as it is, all I'm going to have to do is subtract 5x from both sides, and that will give me y equals negative 5x plus 3, so that the slope of the given line is negative 5. However, we are looking this time for, in number 12, a perpendicular line. Okay, follow these steps when you have a perpendicular line. A, write the slope of the given line. Negative 5. 2, that's B. Write the slope as a fraction if it's not written as a fraction already. Write the slope of the given line as a bad word, I know. Should never say the F word, the math F word, as a fraction. Well, negative 5 equals negative 5 over 1. That was easy. Now C is also not hard. Write the slope in step B I should have said write the reciprocal of, but no, as its reciprocal, a little more wordy. All right, the reciprocal of negative 5 over 1 is negative 1 over 5. Now D, change the sign. So all I have to do is change the sign of that. It's negative here, so I will write it as positive here. That's how you find the slope of a perpendicular line from the slope of the given line. The slope is 1/5. So now I write the point slope formula. Y minus 5 equals 1/5 times x minus 4. Let me make sure that's right. Yes, it is. Okay. Now I'm going to multiply both sides of the equation by 5. Now 5y minus 25 equals, the 5's cancel, I'm left with 1/1, which is 1. 1 times x minus 4 is x minus 4. Now everything is normal. Actually, once you start this, the only thing that's different is finding the opposite reciprocal slope from the slope of the given line. You take the reciprocal and change the sign, or you go through these A, B, C, D steps. It's an algorithm to change the slope to the opposite reciprocal slope. Okay, now back here. To solve for the y term, I add 25 to both sides of the equation. Negative 25 plus 25 is 0. I'll have 5y equals x. Now I have minus 4 plus 25. That's going to be plus 21. And then I divide by 5. However, before I do that, it's a good idea to put my 1, my invisible 1, in front of the x. Divide by 5, divide by 5, and divide by 5. So I will have y equals 1/5 x plus 21/5. Let's see. There now. All right. 1/5. So 1/5 x plus 21/5. Oops. (21/5). Yay. Next question. Remember, you can always go back. You can slow down the video. You can speed up the video. Not a problem. Here's the next problem. 13. This must have been 12. Did I write that down? No, I wrote number perpendicular. So let me number 12. Number 13. Okay, this is perpendicular. Oh no! Yes. Perpendicular. Okay. We have the given point 6, negative 8, and the given equation 7x plus 3y equals 2. Notice I wrote it spread out so that I could do this. Minus 7x minus 7x plus 2. Because 2 is positive. See, 2 is positive. So now 7x minus 7x is 0. I'm left with 3y equals negative 7x plus 2, and I divide by 3, divide by 3, divide by 3, but it is the slope I care about. Well, no, I'm not going to write it there. I'm going to write it here, the slope of the given line. Negative 7/3. Now, A. The slope of the given line is negative 7/3. I don't want to write in red. Negative, there, 7/3. Now B. Write it as a fraction if it's not already written as a fraction, but it is. C. Take the reciprocal. Negative 3/7. And D, change the sign to 3/7. Do those 4 steps a few times. You won't need to worry about it. You'll just do it automatically. Okay, 6/8. That is 6, never mind. Y minus y1 equals m times x minus x1. So y minus negative 8 equals 3/7 times x minus 6. Multiply both sides by 7. No, don't you do it yet. Y plus 8 equals 3/7 times x minus 6. Now do it. Times 7/1 times 7. Now distribute 7 times y and 7 times 8. That will be 7y plus 56 equals, the 7's cancel, leaving 3 over 1, or 3. So 7y plus 56 equals 3x minus 18. Now subtract 56 and subtract 56. Seven y equals 3x minus 18. It's like taking away 18 and then taking away 56 more of whatever. You add the two numbers together and then put a negative sign in front, making sure that's right. All right, and divide by 7, divide by 7, divide by 7. And I'm going to check out what 74 over 7 is. I might even put the sign on it. Negative 74 divided by 7. Nope. Okay. So our equation should be y equals 3/7 x minus 74 over 7. That doesn't feel right. Let's see. Fraction 3/7 x minus fraction 74/7. Whoa, I was sure I had that wrong. All right, now let's do this. See, these are not really as difficult as they seem to be. 0,5, with the given line being 4x plus 5y equals 8. And it is perpendicular. So I use this line to find the slope, which means if this had been -8, you would have put -8. All right, this is 0 plus 5y. Don't ask me why I'm going back and doing this in a, I don't know, more basic way. I just kind of felt like it. 5y equals -4x plus 8, divide by 5, divide by 5, and divide by 5. So we now know that the slope of the given line is negative 4/5, which means what? It means you don't really have to go through those 4 steps now that you're getting the hang of it. Y minus 5 equals negative 4/5 times x minus 0. Well, this one is going to be easy. Y minus 5 equals negative 4/5 x. We absolutely did not have to multiply both sides by 5 in this case. Uh-oh, look what I did. Look what I did. And I was being such a smarty. This becomes 5/4. Duh. 5/4. 5/4. Now, add 5 to both sides. And 5 to both sides. So the answer to this problem should be y equals 5/4 x plus 5. Let's see. Five-fourths x plus 5. Yeah, all right. Now, all the students asked me about was these parallel and perpendicular lines. So I'm going to leave this at this because that's what they asked for. But I have a feeling they might have a problem with the word problems. What should I do? The smart thing would be to do the word problems, wouldn't it? Yes, it would. All right, these are called applications. All right, let's read it. A school club is raising funds by having a shred it day. To shred the documents, the club is charging $12 for the first 3 paper bags full of documents, and then $2 for each additional bag. We could say for each additional bag after the first 3. So if I were going to draw a picture of this, I would say that if this is a paper bag, okay, if you only bring in 2 bags, you're still going to pay $12. So this is like a flat fee. And then for however many other bags you bring in, you're going to pay $2 each. So the equation of this line would be, okay, you've got the cost, they're calling that C of X, is going to equal a flat $12 plus 2x, but of course the really correct way to write this is 2x plus 12. But you have to remember that x is the additional bags. Okay, so I'm going to formulate a linear equation. 2x plus 12. Now I have to graph it. Use the graphing tool to graph the function. 2x plus 12. Okay, so I'm going to be graphing a line. Now, 2x plus 12. 12 is the y-intercept. Zero, 12. And then I'm going to go up to 1, 2, and over 1. Save it. Check it. Oh! Now, use the graphing tool. Oh, I did that. The total cost of shredding 5 bags is x does not equal 5. X equals this number of bags minus the first 3. So it's going to equal, if we calculate this on the paper, 5 bags is going to equal 2 times 5 minus the first 3 bags plus 12. Because that 3 is getting paid for out of this. So, 5 minus 3 is usually 2, right? So 2 times 2 is 4, plus 12. That's going to be 16. Now let's just see. If I bring in 5 bags, well, doesn't agree with me. But 5 minus 3 is 2. And that would be 16. So let's see. Yeah. Okay. Now, one more. With a caveat, I am not going to do all these again. I think this one is easier, as I recall. The Fax Corporation bought a fax machine for $700. The fax machine depreciates at a rate of $25 a month. That means every month it's worth $25 less. Okay, so this is the rate of change, 25 per month. So what we're going to do is we're going to let this equation be down $25 a month, where X is the number of months, plus 700. That is, it started at 700 and then goes down $25 a month. Now, it's more understandable if you write it like this, 700, and then it goes down $25 every month. But we normally write it with the minus 25 first. So find a function that can be used to determine the value of the fax machine T months after purchase. Okay, that means I cannot use X. I have to use T. Most of the time, T and X are absolutely interchangeable. T, T. I always put a curl on the end of my T's so it won't look like a plus. Okay, so negative 25T plus 700. Okay. Complete the model. Okay. It's depreciating. That means going down. This line would say, oh, the value stays the same no matter what, forever. This line would say the value is going up. These two lines both say that the value is going down. But we have to decide which one is true. We have to find out how many months will it be until the value of the fax machine is 0? I mean, is it that or is it that? Let's find out. If f of t, the value of the fax machine, can be given by negative 25t plus 700, then when the value is 0, what is t? I am going to add 25t over to the other side of the equation. So that gives me 25t equals 700. And when I divide by 25, this is what I will get. 700 divided by 25 is 28. 28 months. Both of these graphs go to 40 months. Now, 28 is more than halfway to 40. This point is not even halfway to 40, whereas this is more than halfway to 40. So I am going to vote for B. And I was right. And that's it. Okay, class, you have a special treat. I have now done these problems twice for you. Enjoy them and learn from them, okay? And I'll see you next Saturday where we will go over the practice quiz, the practice exam rather. Okay, talk to you then. Bye-bye.